Hello, ladies and gentlemen. I hope you are fine and you are feeling the fire as we move on with our investment appraisal topic. And we are almost nearing its epilogue. And before we close the chapter, we just want to look at these two legal items. Okay, we are only going to look at two topics, subtopics, which are, we are left with. The first one is sensitivity analysis, all right, and then we'll look at uh, expected values, all right. These are also part of those assessments which are utilized when the entity is being faced with risk and uncertainty in its investment appraisal. All right. Now, when you are talking of sensitivity analysis, we are simply saying that we want to know what will happen if there is a change in one variable. What is going to happen to our net present value or to the net present value of the investment? Is it going to become negative or it will remain positive? All right. So sensitivity analysis is just the process of analyzing a change that is going to be made when one variable is changed. Okay, what is going to be the effect if a variable changes? All right. So, for example, there could be a change in the selling price. If there is a change in the selling price, if the selling price goes up or down, what is going to happen? So, let's talk of sensitivity analysis. Okay, so the idea is we first have to calculate the NPV of the project. All right. Then we calculate the percentage change in each variable. Okay. We have to determine what change in each variable would result, okay, in an NPV. Okay. What change in each variable would result in an NPV of 0. Okay, of 0. What change? We have to determine what change should occur in one variable or in another variable for the NPV of the whole project to become 0. Okay, and this will actually enable us, okay, to ascertain which variables require critical attention. All right, because if we do not do that, then we'll just proceed with our eyes blinkered. We do not want that situation in investment appraisal. So sensitivity analysis just gives us the focus so that we become contingently aware of what appropriate action to take should things turn this way. All right, we just do not want to proceed without knowing, without having some buffer, without having some contingent planning. All right, so the purpose of sensitivity analysis is to inform us of the worst case scenario as well as how to attend to those scenarios should they occur. So let us look at example Caledina and see what is going to happen. Caledina has just set up a new company and estimates that the cost of capital is 15%. Her first project involves investing in $150,000 of equipment with a life of 15 years and a final scrap value of $15,000. The equipment will produce 15,000 units per annum, generating a contribution of $2.75 each. So that's the contribution of the equipment. Of the units which this equipment is going to produce. The estimates, she also estimates that additional fixed costs will be 15,000 per annum. We understand that 15,000, fixed costs are irrelevant costs, but when they are additional, they become relevant. Okay, because they are now related to this particular project. So they become relevant. Now, determine on the basis of the above figures whether the project is worthwhile. So using these figures, we need to determine if the project is worthwhile. So that one is actually the easiest task for us. All right, so we can simply come up with our present value table. All right, where we have got the year, all right, the cash flows, the discount factor, 8. In this case, we are told the cost of capital is 15%, so discount factor at 15%, then the PV. All right, so in year 0, we've got the cost of the asset, and we are told the cost of the asset is 150,000. So 150,000, and this becomes 150,000 here. Then we are also told that the equipment will produce 150,000 units per annum, generating a contribution of 275. So the life of the equipment is 15 years. So we are having a constant, 1 to 15 years. We are having a constant income, okay, constant income flow throughout the years of the project. So or constant cash flows. So this is a form of annuity. Okay, we're having an annuity over 15 years. All right, and this is going to be the contribution. So the contribution in this case, we are having 15,000 units multiplied by $2.50. That's $2.75, which is the contribution per unit. And if we do that, that's 15,000. 15,000 multiplied by 2.75, that's 41,250. So that's 41,250. Then we discount by, in this case, we have to determine the annuity, the amount of this annuity over 15 years. So we multiply by the annuity factor for 15 years. Okay, that is going to be our discount factor. So the annuity factor 15 years is going to be from the annuity tables, that's 5.847. Annuity factor 15 years at 15%, that's 5.847. So if you multiply that annuity factor by 41,250, we are going to get 241,189. Then we are also told that if we do this project, there is additional fixed costs. So there is a annuity factor for fixed costs required, fixed costs additional, and we are told they are 15,000 per annum. So 15,000. Remember, this is now an outflow, so it's negative, but we are going to use the same annuity factor there. All right, and if we multiply, we get a negative 87,705. There is also going to be a scrap value of 15,000. So in year 15, in the 15th year, we are going to have a scrap value of how much? We are told it's 15,000. Positive figure, and the discount rate in year 15, that's 0.123, okay, from the PV tables, and we get 1845. Then we add up, we get our NPV. All right, NPV would be positive 5329. Obviously, using these figures, then we can see that the project is worthwhile and should be accepted because the NPV is positive. Now, we then have to calculate the sensitivity of the project to the change in one of the variables, and we want to ascertain what will happen to the NPV if the initial investment changes. So if there is a change in the initial investment, what will happen? All right, so let's determine that. So we know that our initial investment is 150,000. So and our NPV is 5,329. So therefore, sensitivity of initial investment. All right. So number one, sensitivity of initial investment II. Initial investment is equal to the NPV 5329 over the initial investment of 150. Okay, multiply by 100%. So that's 3.55. So what it means is that if the initial investment increases by 3.55%, we are going to end up having a negative net present value. All right? If the initial investment increases by 3.55%, then we'll end up having a negative NPV. Okay? Okay, now let's look at the sensitivity of the sales volume. Sales volume sensitivity. This is determined by the NPV divided by the contribution itself. All right, because contribution, remember, is selling price minus the variable cost. All right, so usually the volume is actually determined by that relationship. So contribution, the PV of the contribution was 241,189. Okay, just from our computation there. Just from our computation here, you can see that the present value of the contribution was 241,189. So that's how you proceed. Multiply by 100%, and we must get 2 to 1%. Now, do you think if the sales volume, if the sales volume is increased by 2.21%, the NPV is going to become negative? Obviously not. Remember, we are doing this assessment to determine what could get wrong for us to get a negative NPV. All right. So obviously, an increase in the sales volume is not going to give us a negative NPV, but a decrease. So if the sales volume decreases by 2.21%, then we are going to sustain a negative NPV. So if there is a fall by 2.21% in the sales volume, then we are going to achieve a negative NPV. Similarly, if the initial investment cost decreases by 3.55%, then the NPV is not going to be negative, okay, but rather it will increase. But if the initial investment increases, so if there is a plus 3.55% change in the sensitivity, in the initial investment, then we are going to have an NPV which is negative. So simple, isn't it? Now let's look at the contribution itself. All right. 3, sensitivity of contribution. All right. This again is it's just the same as the sensitivity of the sales volume. So we are going to use the same NPV or NPV as 5329 over the contribution PV of 241. Okay, 241, 189, apply by 100%, and we are going to have a decrease of 2.1%. So a decrease in the in the contribution by 2.21% is going to affect our net present value to become negative. All right, so let's move on to 4. Sensitivity of fixed costs. All right, our NPV 5329, and then the PV of fixed costs. The PV of fixed costs, we have determined it to be the PV of fixed cost was negative 87,705. So we come here and say 87,705 multiplied by 100%. So obviously, if we are looking at the revenue side or the income side, like the contribution, we expect that if there is a fall in the contribution or if there is a fall in the sales volume, then we are going to have a negative NPV. But on the cost side, if the fixed costs are going to increase, then we are going to be in trouble. The NPV is going to become negative. So in this case, we are having a sensitivity of plus 6.08%. So which means if the fixed cost, if additional fixed costs arise by 6.08, then we are going to be in trouble. The NPV will become negative. Then sensitivity of the scrap value. Remember, scrap value is an income. Scrap value. Okay, sensitivity of the scrap. Remember, this is the scrap, ladies and gentlemen. Of the scrap. The scrap always put the NPV on top over the scrap value. The scrap value, we are told it's 15,000. All right. Sorry. The final scrap value is 15,000, but after discounted, remember we are going to use discounted values. So the PV value. So that's 1845. Always use the PVs. So that's 1845 multiplied by 100%. And we are going to have a negative 289%. All right. So if the scrap value falls, by 289%, okay, the scrap value falls by 289%, then we are going to be in trouble. Okay, that's the idea. Okay, now let's do the last bit of the question. The numbers. Item 6. Okay, the sensitivity of the cost of capital. All right, item 6. Sensitivity of the cost of capital. Remember, the cost of capital is the one which we have used to discount everything. Okay, the discount rate of 15%. Okay, so at the discount rate of 15%, we ended up having the NPV of 5,329, which was positive. All right, so how sensitive is this discount rate to changes, okay, in the economy or changes? How sensitive is it to an extent that we end up having an NPV of 0. So to what extent shall the discount rate change, or shall the discount rate fall or increase? But in this case, it should increase for us to have an NPV of 0. All right. If it falls, then the NPV will continue to be larger and larger. But if it increases, if the rate increases, then the NPV decreases. So to what extent are we going to have an NPV that is going to be 0? So we are going to use what is called the internal rate of return, right? So that is going to tell us what is going on. So we are going to calculate the IRR, all right, because this is the rate at which the NPV is going to be 0. All right. So if we know this rate, we can then determine at what percentage is the discount rate going to increase, so that we end up having an NPV of 0. So let's have our NP table. Okay, we have got the year, all right, the cash flow, the discount factor at let's say, because we have already determined the at the rate of 15%, we get a positive NPV. So we want a higher rate. So let us, hypothesize with a 20% rate. So at 20%, discount factor at 20%, what is the PV? Okay. So the investment, okay, is in year 0, and it's a 15-year investment. So we're having a 15-year annuity, okay, as usual. And the initial investment was 150,000, okay, 150,000, and the discount factor at 20%, that's 1 for year 0, all right, and obviously here 150, all right. Okay, all right, so we just do as we did in our previous, just have to copy and paste some of the figures. Okay, these figures, for example, the from this point, this figure, you can just copy it. This one, we can copy it. So 41,250 for the contribution, 41,250, and then for this, okay, and the figure there for the fixed costs, 15,000. All right. All right. Okay. Okay. This was what. Okay. Our contribution. That's okay. So we then have to use the discount factors, annuity factors at 20%, 15 years. So that's 4.675, 4.675. All right, and then for the scrap value in year 15, the scrap was 15,000. All right, and this should be 0.65. So if you do your multiplication, you must get 192,844 and 70. Remember, the fixed cost is a negative, it's an outflow. 125, then 975. Okay, so that is that. So 15,000 if it is going to be received in 15 years to come. It is worth 975. Wow, that's the time value of money. Okay, so if we add up, we get negative 26,306. All right, now we have got the NPVs for two discount rates, two NPVs, and two discount rates. So the IRR, we know that IRR is lower percentage plus bracket NPV of lower percentage divided by NPV, lower percentage minus NPV of higher percentage multiplied by higher percentage minus lower percentage. So in this case, we are having the lower percentage. Our first percentage was 15% plus the NPV of the lower, as we determined, was 5329, or divided by 5329 minus the NPV of higher percentage 20% was negative 26,306. Okay, negative 26,306. So negative ending up being a plus. All right. Then multiply by higher percentage. That's 20% minus 15%, higher minus low, that is 5%. We end up having 5%. And if we solve, we are going to have 15.84%. Okay, 15.84%. All right, so you can see that there is a movement. Okay, there is a movement from the original 15%. Original rate was 15%. So the movement or change was only 0.84%. Okay, so sensitivity of cost of capital is equal to 0.84 over 15 multiplied by 100%, and this gives us about 5.6%. All right, so this is a cost of capital. So which means if cost of capital increases by 5.6%, then our NPV is going to be 0. Why? Because IRR is the rate at which the NPV is going to be 0. All right. So if our cost of capital increases by 5.6%, then we are going to have a 0 NPV. All right. And any rate above that rate, that 5.6%, any increase above 5.6%, then our NPV is going to be negative. Okay, that is that, ladies and gentlemen. I hope you have enjoyed. Let us now meet one another in our final segment on expected values, and we call it a day.